Cool. So we have a really interesting topic that um, could get really dry going down into like all like the details and stuff. Could be really fascinating for you. We'll see. But what's really interesting about what we're going to be talking about is we're going to look at how information is sent across the web. And so there's really one key technology or key thing that is used to transport this data. Before we talk about it, some internet terminology. Client and server. So you'll hear me use the phrase client and server a couple different times. And so just wanted to explain that real quick. So a client is going to be like an application that you like visually interact with. And so it could be an app on your phone, it could be whatever you're interacting with. It could be a website that you're interacting with, you're interacting with the client. We're used to interacting with clients. It's the visual component. Servers, on the other hand, are typically hidden in the background, and often what their role is to store data and retrieve data. So we may have encountered by now that if we wanted to save data on a website, it disappears as soon as we press the refresh button. So we need a place to put the data, and so therefore we need a server to send the data to, so it has somewhere to live. And so when we talk about clients, think about like a website that we're interacting with. When we talk about servers, think about the thing that the website might be talking to and sending the data to and retrieving the data that's associated with like a database. This part we don't need to go too far down this rabbit hole, but segments of a URL. So notice it starts off with HTTP or HTTPS, and then we have the subdomain. And so for like Gmail, you'll see it would be like mail.google.com. So mail would be the subdomain. www or www is a subdomain. And then we have the domain itself, google.com. And then the .com is the top level domain. After that, we have the path, and the path can even have variables in it. Cool. So we've arrived to our main topic as far as talking about how data is passed around on the internet, and that's going to be HTTP. So we've all interacted with HTTP before. So every time we go to a website, we see the URL HTTP yada yada, and so we know that it exists. But let's look a little bit closer at it. So while we're interacting with a website, we see the front end or the client that we're interacting with. What we don't see is there are often hundreds of HTTP requests happening in the background that we don't see. And these are doing all kinds of things. Like, for example, when someone writes a comment on a blog or a post and they press enter, an HTTP request gets sent off, and a bunch of magic happens in the back end on the server side, and then that's all happening behind the scenes essentially. And so we're going to look a little bit closer at what exactly the broader spectrum of HTTP is, besides just what we're used to, just going to a website. So HTTP is technically a set of rules that define how information is transmitted over the web. A rough analogy would be to consider just the fact that we have so many different like traffic laws and rules of the road. A lot of them we don't really think about. It's just how things work when we're driving a car. And so HTTP is sort of like the traffic rules for the internet. It's a real rough analogy, but it might help to think of it that way. Cool. So terrible question. What does HTTP stand for? Anyone? Yes. And to check that, I'll have to look back because I don't know. Hypertext Transfer Protocol. Yes, exactly. Yeah, I'm not super concerned with knowing what the letters for, but I just thought I'd throw that in there. But yeah, great job. Cool. So there are different types of HTTP requests. When you go to a website, the web browser like Google Chrome or Firefox, in that browser, it does a GET request and it gets the website. And so I don't want to go too far off on this analogy, but you could almost imagine it as like if you put a CD in a computer or a PlayStation or something like that, and your PlayStation or computer reads the application off the CD, it's almost like doing a GET request, it's getting the information. And so the website, you go to like wikipedia.com, it sends an HTTP GET request, it gets the data, and then pulls it back, and now we have a website that we're looking at. The requests that we don't see going on in the background are other GET requests, post requests, put requests, delete requests, and there's a couple others as well. Another interesting thing about HTTP is that it can contain like a body, which is like a body of content. And so we'll talk more about JSON in the future, but JSON is essentially a very common data format that HTTP is sending data around with. So when an HTTP request is sent off, so maybe we're doing a post request and we're sending data off, or we're doing a GET request and we're requesting something, some data back, we will get a response. And so we have a 200 response, 404, 500 response. There's a bunch of different like other numbers, like you can think of these as like series of numbers. So like the 200 series are good. This is really okay. The 500 series are, there was an error on the server, something like that. So question, what is a 404 status code? Yes. It is technically, you could consider an error. If you were to give a 404 status code an error message, what would that message be? Resource does not exist on the server anymore. That's pretty close. That's accurate. It's a little bit more broader than that, which would essentially be the resource has not been found. And so maybe it existed at one point, or maybe it never existed. It's just not found. And knowing what all the status codes mean, it's not really something you need to memorize, but it's nice to be vaguely familiar with what the different things are. There's actually a status code that is I'm a little teapot, and it came out as like an April Fool's joke and then never went away. There's a lot of things like that. Cool. So with these HTTP methods, GET, like we're talking about, its intention is to retrieve data. Post is to submit data to a resource. Kind of already talked about this. An important note here on this slide is that last bullet point, which is a GET request is the only request your browser can make. Okay, so your browser can only make GET requests. So how does that work? We have all these other requests happening in the background. Essentially, your browser makes a GET request and it gets the website. The website's code, it gets JavaScript and stuff, that is what makes all of the other requests that might be happening in the background. I think I'll pause here. I've kind of rambled through a bunch of different data. Curious if you have questions, things like that aren't quite clear. Yes?
So let's say you were logged in to Instagram or something on Google Chrome, and when you like something and it updates that, isn't that like a post method?
Right. So the question was, let's say you're on Instagram and you like something. Would that be a post method? Most likely, yes. So if I had to guess, I would say, yeah, it would be a post method. It's possible that they used another method. It's also possible they used another method incorrectly, but it's most likely going to be a post method, right?
So doesn't that break the last rule of a GET request is the only request a browser can make?
Right. So that's a good question. So if we press a like button, and that like button sends a post request to tell the database, hey, this has been liked by this user. How does that happen if we cannot do anything other than a GET request on a website? So what happens, long story short, would be when you press a button, there's going to be very likely a JavaScript event listener that says, hey, this button's been clicked. And then JavaScript is going to do a fetch request, which I think we'll get to, I think it's next class, a fetch request, and the fetch request is making the post request. So JavaScript, which is inside this website that the browser loaded, is the one that's making the request. But the web browser itself, the web browser application, isn't making the post request, if that makes sense. Right, so for example, you can, let me think here. So in like the URL bar, you can never like put in an address and make that a post request. If you put in an address in the URL bar, it's always going to be a GET request, right? And so, yeah, hopefully that's clearer. Cool, awesome. Other questions? No? Good to move on? Cool. HTTP headers. So when we're sending an HTTP request, there's a lot of information that gets sent. Whether we as developers realize it or not, when we set up a fetch request or just go and search a URL in the browser, there's a lot of information in this HTTP request. So one of the bits of information that's really important is the request method. So if it's a GET request, a POST request, a DELETE request, that's important. The request will contain the status code once it resolves, and we get a status code back saying if it was successful or if there's an error of some sort. The headers can also contain things like the content type, if we're trying to send an image or a document or a script down the pipeline. There's a lot of information in the HTTP headers, and we'll look at Wikipedia a bit later and just see what all of their HTTP requests look like, and kind of get a feel for like what the different headers look like. Cookies. So cookies are, in terms of like the world of web development, they're very useful. They're also somewhat controversial because there's a lot of concerns with cookies being used to spy on people, right? Or just gather too much information, if you call it spying or not. And a good way to, well, we don't need to talk too much about like cookies and how they're built, but just know that with an HTTP request, you can send and receive cookies with an HTTP request. Where cookies actually live, though, is going to be inside your browser. That's where they live, but they can be sent with an HTTP request. An example of like when a cookie might be used would be if you've ever logged into a website and you click the remember me or don't ask me to log in again. It's very likely, I don't know of any other way to do this. What it's doing is it'll create a cookie that lives in your browser, and then when you go to log in again, it will check for the cookie, and if you have it, it will log you in. And so that'd be an example of when a cookie might be delivered with an HTTP request. We'll touch on this one quickly. So HTTPS versus HTTP, the difference between those two things. Essentially, HTTPS is very similar to HTTP. The key difference is that it's secure and it has encryption. In order to use HTTPS, if you were like creating a website, there's a process to get it set up. And essentially, I actually don't know the whole process verbatim, but one of the things you'll need is an SSL certificate. And so that's like a whole other topic on its own, is setting up HTTPS. And so if you're using services, sometimes they'll have that set up for you. Cool. So speaking of spying, let's check out Wikipedia so we can get a feel for how all these requests are happening. I can go so I'm in Chrome right now, and I can press F12 to get to the developer tools. Alternatively, I'm sorry, I'm having a hard time talking. We can right click and click on Inspect. Okay, and so there's a lot of stuff in the developer tab. I would say like when I first was learning how to code, actually for quite a while, I kind of avoided the developer tab because there's just too much in there, and it just felt like it was overwhelming. But to break it down to you, the three tabs that I use the most in the developer tabs is going to be the elements. So this is the HTML. The console, this is the JavaScript console. Right, so we can do stuff in here, and we can see different console outputs inside the console. And then what's relevant today is we have the network tab. There's a bunch of other tabs, as you can see here. They're kind of compressed, but all right. So let's see here. I'm gonna get rid of some of this unimportant stuff. Right, I'm gonna reload the page, and so. The first thing we got, sorry, I want to make this a bit easier to see, but my mouse, for whatever reason, is not giving me the ability to resize things the way I want it to. Maybe I need to zoom out. Right, so ignore a lot of the mess, but when we loaded this page, the first thing that came up is this this GET request right here. And so our browser made a GET request to https://wikipedia.org. We got back a green status code. Green's just Chrome's way of telling us it was successful. There's a remote address. This is like the IP address of the website. We don't really care about that right now. I'm going to scroll through this. There's just a lot of stuff here, and most of it we don't care about unless it's something specific. But here we have our request headers, and so when the browser sent the GET request, it sent it along the method GET. Right, so kind of a lot. And so to show what it sent back, when the browser made the GET request, it sent back this HTML right here. And that gets rendered out as the web page. Cool. So the next thing we're going to do is we're going to search something on Wikipedia, and we're going to see it make a post request. But before I do, questions on what we just looked at, this GET request in the inspector tab. No questions? All right, cool. So let's make a post request. Let me clear things out. Let's see. You can see as I'm typing, there's like a bunch of stuff happening in the background. But we're not going to worry about all that right now. Let's just search. And a lot of stuff came up, but I'm going to look for the... I think this is it. No. Yes. There's a lot going on here. So the way their search is set up is actually not a post. It crafted a URL, which was just the web address of the LaunchCode page. So the way Wikipedia is structured, it's all very, like the name of the page is the name of the website. And so what it just did is when I typed in LaunchCode here, I'm making an assumption here, but I'm assuming that the JavaScript on the back end took that string and then forwarded me, made the GET request to get the information. Cool. Did that make sense? As far as like how that search process worked, we can try to look at a code version of that as well. I guess did that make sense? Is probably not the right question, but just questions in general. Yes. Right. Yeah, I was actually expecting it to be a post request, and I made a bad assumption there. And so I'm assuming how it handled it is it took the text out of the HTML form and just appended it to wikipedia.com something, and then did a GET request there. There's so much like chatter in the network logs. It's hard to like quickly parse. Okay, what exactly happened? Let me see if I can find a better example of a post request. So if we logged into anything, I would imagine that it would end up being a post request. So it would be something good to log into. I don't think I'm logged into CodePen here. Right, so let me try to log into CodePen real quick. I'm just going to use random stuff. Test at test.com. Log in. Let's see what this did. Right, so I attempted to log in. It did make a post request to codepen.io.login. And so a question that you might have is, okay, how did it send my username and password? What we can see here in the payload, so this is what was included in the HTTP request. We have the email and password that was sent as part of this post request. And its response is this JSON object right here. And so that gave us this text right here. This username or password you entered is incorrect. Cool. Nice. So questions on that before we continue on? Yes. Right. So I guess I should comment on that. The thing about traffic laws is sometimes they're suggestions. And the thing about HTTP rules is sometimes they're also suggestions. There are certain things about HTTP that you're kind of stuck with. So for example, with a GET request, you're not going to be able to send information with that, unlike a post request. But in this example, how the developers chose to structure this, they chose to return a 200 even though my login information wasn't valid. And so that was a design decision, and I'm sure there was a good reason for it. But yeah, so yeah, I don't know if that's a good enough answer. But I will say, in my professional experience, I have very rarely seen a website like that perfectly follows the HTTP spec as far as like this should be this. I feel like I should actually pull that up real quick. I wonder if Wikipedia has a nice summary on this. This is a lot. I don't want to go too far down a rabbit hole here, but right. Cool. So we're gonna shift gears here and talk about the second topic, which is going to be HTML forms. The reason why they're relevant is oftentimes a form is going to be how users inputting information into a website. So if they're logging in, they're usually logging into a form, and then that ends up being sent off as an HTTP request. So you may have seen forms come up before. So essentially they're written with HTML, and they have like various things like text boxes, check boxes, radio buttons, drop downs, all these different types of things. And all of these things are designed to collect the user's input. So here's a code example. So we can see everything is inside the form element, the HTML element. And then inside of there, we have these things called labels. We have inputs. And then at the very bottom, you'll notice an input with the type of submit. And you might think, well, that should be called a button, because there is something in HTML called button. But typically for a form, they have a special input type that is for submitting the form. Just generally speaking, text inputs are used to collect everything from like email addresses, name, etc. Checkboxes are more for like yes or no type questions. Drop downs obviously is for when you might have like a list of different things you want a user to select from, and then you can have buttons in the form to submit the form or to reset the form, etc. Now I think I get to this a little bit later, but I wanted to mention something about form validation. So if I was to say form validation, I'm curious if anyone would have a definition for that. What is form validation? Yes. Making sure that the data submitted is valid. Yeah, that's a pretty good answer. That is a good answer. Right, so if a user submits information, let's say there's an email box on our form that we created, and they type in something that's definitely not a valid email. Maybe they type in their phone number instead. We as developers should probably have something in place that tells the user, hey, that's not a valid email, please enter a valid email address. Because an email address has a structure to it, right? A phone number has a structure to it, and so we should be able to validate that and see if it's actually what we're asking for. Cool. So when an HTML form is submitted, it's going to make likely either a GET or a POST request. Kind of have that idea here. So how do we do that? How do we make a GET or a POST request or a different type of request with a form? So a form has an attribute called the action attribute. And the action attribute is essentially the URL where we are sending the data. And so hypothetically, if we had like a server that we're using for the user to log into, and they enter in their username and their password into the form, the action may be the web address of the server, the HTTP address of the server. And so then when the user submits the form, it sends the data to the server. So this is like one of those HTTP requests that we were talking about earlier that's happening in the background. An alternate approach to just using the action attribute inside the form would be to use JavaScript. We can do a lot of things with JavaScript, and one method for forms is instead of using the built-in action attribute for the form, we can just collect all those values with JavaScript, save them in variables, and then make a fetch request and just send all of those off. The reason why you might want to do this with JavaScript is if you wanted more control over things like the form validation and the actual data that's being submitted. Otherwise, you can just use the built-in HTML stuff. And I wouldn't worry too much right now about using fetch. For this, I'm just throwing that out there as like an alternate approach. Cool, so code example, I think this would be good to jump into. I put the GitHub inside the slide deck in case you want to reference it later, but I have it on my desktop, so we'll jump there. Cool, so you'll notice that I only have one file. I don't have a JavaScript file here. I just have an HTML file. There's a README, but it's not doing anything. You can ignore that. Right, so if I zoom out, you can see there's 24 lines of code here. And so let's look at this. So we've seen HTML before. We know that typically all of our stuff is going to go inside the HTML element. And then we have a head element with all of our metadata. We have the body element with all of our visual data that we've seen before. Up here is a header tag. Let me zoom in again. Up here is a header. It's just a title. It's just text. It's not doing anything special. And then we get to the special stuff. And so here on line 8, we have our form. And so everything from here all the way down to here is our form. Inside the form, we have probably the next most important thing to point out is the input elements. So we have input for the name, an input for the email, and this is also an input right here called text area, and this is going to take in, it's very similar to just a text box, but we'll see it visually here in a moment. And then finally, we have the button that actually submits the form. So I'm going to use an extension in VS Code that I think would be worthwhile for y'all to have. This is something called Live Server. This is a tangent, so pardon me here for a moment. But when we get to next week's or next class's studio, it's going to work a lot better if we use Live Server. And so I'll show you how to set that up after we get through this example here, because I think it's worthwhile to show. So anyways, so we've got our form, our labels, our inputs. The labels are just labels, right? So let's look at what this looks like. Cool, so nothing super fancy. We have name, email, message, etc. Now I want to show something really interesting. So if you notice for the email input, we have this thing called type equals email. If I get rid of that, oops. If I get rid of that, and I were to type in a phone number here, that should have complained. Let me see here. Maybe I need to take this on or off. I am expecting that. Oh, I know what's happening. It's not complaining because I don't have the type to set to email. My brain got that flipped. So if you notice, I have a value in here that is obviously not an email. I can put numbers in here. I can just put random text in here. However, if we set the type of the input, type equals email. Y'all couldn't tell my brain's struggling today. Make sure that's saved. Let's go back here, refresh. Now if I try to put in nonsense information, I'm going to expect this to complain because I've set the type of the input to email. Right, and it doesn't let me submit the form. It's giving me this error that says, please enter an email address. And so that is a very useful built-in piece of form validation that we can just take advantage of. It's possible for us as developers to write custom validation for email addresses or for anything, for any input. Like let's say, for example, you're working on an application for an insurance company and they have like a certain format for the member IDs. You might be able to validate if the user enters in a valid member ID, and then you could send a message like, that's not a valid ID, get this placed on your card. There's a lot of different things we can do with forms, but the built-in validation is super convenient. Cool, so now this form, if you notice, it has an action right here. And so the action, it's this test URL. This URL is just meant to test it. If this was a real world application, this would probably be like a server that we're sending data to. But here we're using this http://bin.org. It's a website that's just made for sending test requests to. Our method is post. So we're going to make a post request with this. So let's look at the form. We'll say devs, the name, dev8@gmail.com. That's the address. The message is hello. And so I want to see the post request when we make it here. And so I'm going to click on it, inspect, go to the network tab. And when I press submit on the form, it should create a post request. And there we have it right here. Ignore this for now. So we can see that when we press submit, it created a post request. And so let's look at the various elements of this post request. We have a status of 200. It's good. There were no cookies set with that post request. We didn't really have anything setting that up. And then we can see in the request, I included form data with it, which was the name, the email, and the message. So all of that is being included in this HTTP request that gets sent to http://bin.org. Cool. So pause here. Questions on this example? Yes. I'm sorry, if you had to add one more. Another button to cancel, like to reset the form? Right, so I know in JavaScript there is a method to reset the form. I might need to Google it real quick to see what the best way is. So the question is, like, how can we add a button that resets the form and clears everything out? There's an input type of reset. So let's go ahead and add that to the form. Okay, so we added a reset button. Let's go back to the form. Cool, so we can see a reset button just showed up. This is what we just coded. So I'll add some more information here. And if I press submit, it'll still try to submit the form. And if I press reset, it clears everything out. So that's another convenient built-in thing. Yes? Right, okay. That's a great question. So up until here, when we talk about HTML, we've talked about an opening and a closing tag. And then both of them together makes up the element, the HTML element. And so here we have an example of an HTML element that is self-closing, meaning that it doesn't have a closing tag. You could, I believe you could, there's some examples in which you could, it can be either or. Like I think with a div, it can be either self-closing or having an opening and closing tag. And so generally speaking, it is a best practice to indicate that it's a self-closing HTML tag with this adding a / to the end tag. So that helps indicate this is a self-closing tag. This is more for the developers and less for the computer. Just going to refresh this and make sure I got my syntax right. Yeah, it likes it. Cool. Can we change the text on the button for like the reset button? Right. Yeah. Let's try that. Undo. Oh, okay. Let's take a look. I changed the name to undo, and it still says reset. Let me think here. How could we do this? Maybe if we added a label, would that change things? Or do we need to go? I'll be honest, I am guessing here. Value, thank you. Sweet. So yes. So great call out. Thank you. Yeah. So in this example, we just saw that if we don't set the value, it's going to default to whatever the button type was in this case, but we can change the name of value. Thank you. Awesome. Other questions? So far, great questions. Yes. Right, so the important part here, if I get rid of all of this right here, and I just leave the type as reset, me jump back to this. This is still going to function how I want it to as a reset button. And so the name, this is useful for various aspects of the form. Like, for example, if you were using JavaScript to pull like a value out of the form, you could reference it by the input name. And then the value is here to change what's being displayed, right? And so you'll notice that the difference between the reset button and the email input, they look very similar. The difference is the type. And we can also see that up here with the text input too, right? Good question. Let's see here. Other questions before we jump back into the slide deck? No? Cool. Okay, so true or false question. Let's do hands up for true, hands down for false. Server side refers to the visible website. Hands up if true. I got no one. Great job. Cool. Yeah, server side is not what we're visibly seeing. This is something in the back end that is handling the data storage and things like that. We talked about HTML form validation. Remember, if we set the type to email, it will validate it for us with the user's inputting. Now that is that's what when we're talking about client-side validation, it's things like that. It's either using like the built-in type equals email type validation, or if we're using JavaScript to validate it, those are client-side validation. Now, a savvy hacker could use a terminal and submit an HTTP request and send values that we didn't get a chance to validate. So let me give an example. I don't think we've talked about SQL in this class yet, but SQL is a database language. With SQL, you can say delete everything if you want to. And the database would be like, oh, you want me to delete everything? Cool, I'll do that. And so what has happened in the past is someone will submit a SQL command in a form that basically says, drop the database, delete stuff. And it goes from the form, it goes to the server sends that command to the database, and it deletes everything. So that is something called SQL injection. Now, if we have client-side validation, we can keep the user from SQL injecting in our form by saying like, it needs to be this way. But in order to actually protect the website from someone that is maybe using a terminal to send these requests, we need something called server-side validation. So client-side validation is things that are useful for maybe your average user, the average person trying to log into your website. Client-side validation is helpful for them. Server-side validation is very helpful to protect against hackers. So an example of what that might look like, it would be something like if the data that you're expecting is an email, you might verify that it's an email on the server side too. And you're probably going to check everything that comes to the server and make sure it's not a SQL command. And so there's various things like that. We're not learning about server-side validation today, but I wanted to bring it up because it's something useful to know that it exists, right? Cool. And last slide here on this topic. So just a few best practices. If you remember that we had labels for the different inputs for HTML form, it's important to be clear, concise, descriptive. Think about like variable names to a certain degree, how we put a lot of thought behind them, except that this is something that strangers could hypothetically be trying to interact with your website, and we'll want clear and descriptive labels. Use appropriate input types when we're talking about validation. This is very useful for someone that's visiting your website. If they type in their email address and they forget like a period in the email address, If you use the correct input type, it will let them know, right? And then, right, so then the last bullet point is essentially the same point I made earlier, which is using the client-side validation. Cool, so that basically sums up slide deck content about HTML forms. We talked about the HTTP requests. And so before we start transitioning to studio time, I want to open up again for questions, anything y'all would like to explore on either topic really, or anything else. Yes?
You said something in VS Code, like live server or something?
Live server, thank you so much. I wanted to show installing extensions in VS Code. So I close my sidebar. Let's see here. Oh, here we go. All right, so in VS Code, if you don't know where your extensions are, you might need to go to View and then click on Extensions. And that will open up this, basically, it's almost like an app store for VS Code. It's really great stuff. And there is an extension called Live Server. And if you have not installed it yet, there will be an install button on it. If you click on that, it will install it. Now, once it's installed, if you have like an HTML website, there will be a button on the bottom right-hand corner of your VS Code down here. You click on Go Live, and that will just pull up your website in a browser. Now, I mentioned that this will be useful for when we do Studio next class, and the reason for that, without going way far down a tangent, is that you are going to be reading from a JSON file from your local machine, and the browser doesn't like that. What the browser is going to try to do is protect you from a hacker, which is yourself, because it sees that your computer is trying to read from a local file on your desktop, and it doesn't like doing that. And so what happens when you use Live Server is everything gets temporarily hosted at an IP address, so like a normal website. And so when it goes to read from that JSON file, the JSON file is also at this IP address. And so your browser doesn't try to protect you from this CORS error, which I'm sure CORS will come up again in the future. The browser's not going to try to protect you from the CORS error because everything is living in this happy place, which is on this IP. So without going too far down that rabbit hole, that would be the reason why Live Server is going to make your life easier next Studio. Cool. Thank you for reminding me about that. That was important. Also, fun stuff. There's a lot of like interesting things inside of the extensions. I can see what I have on this machine. I have something called Indent Rainbow, and so I'll show you what it looks like without it. So if you notice, without Indent Rainbow, that extension, my HTML, you can see how far something's indented by just these lines. But when I enable it, it basically colorizes each indent. And so for me, I kind of like that. It's a little bit easier to see what I'm doing. And so there's a lot of different things with VS Code extensions that you can find that are fun, but I'll stop talking about that. Other questions before we transition to studio time? No? Cool. All right. Yes. How do you enable autosave on VS Code? I would probably need to Google it. There is, here we go, in File, if you scroll down from File, there's an autosave. Are you on a Windows machine? You're on a Mac? Okay. My next step would be to Google on Mac OS, yeah, how to enable autosave. Yeah, things are just a little bit different with VS Code on the different operating systems. A lot of overlap, but some differences. Okay, very good. Thank you all for joining me. Enjoy studio, and I'll see you back here at 8.